Swarm robotics is a new approach to the coordination of multi-robot systems which consist of large numbers of mostly simple physical robots. It is supposed that a desired collective behavior emerges from the interactions between the robots and interactions of robots with the environment. This approach emerged on the field of artificial swarm intelligence, as well as the biological studies of insects, ants and other fields in nature, where swarm behavior occurs. Definition: the research of swarm robotics is to study the design of robots, their physical body and the controlling behaviors. It is inspired but not limited by the emergent behavior observed in social insects, called swarm intelligence. Relatively simple individual rules can produce a large set of complex swarm behaviors. A key component is the communication between the members of the group that build a system of constant feedback. The swarm behavior involves constant change of individuals in cooperation with others, as well as the behavior of the whole group. Unlike distributed robotic systems in general, swarm robotics emphasizes a large number of robots, and promotes scalability. For instance, by using only local communication. That local communication, for example, can be achieved by wireless transmission systems, like radio frequency or infrared. Goals and applications. Both miniaturization and cost are key factors in swarm robotics. These are the constraints in building large groups of robotics, therefore the simplicity of the individual team member should be emphasized. This should motivate a swarm intelligent approach to achieve meaningful behavior at swarm level, instead of the individual level. Simple swarm bots. A lot of research has been put into achieving this goal of simplicity at the individual robot level. Being able to use actual hardware in research of swarm robotics in place of simulations allows researchers to come across and resolve a lot more issues and thus broadens the scope of swarm research greatly. Thus, development of simple robots for swarm intelligence research is a very important aspect of the field. The goals of these projects is manifold, including but not limited to keeping the cost of individual robots low in order to be able to make the swarms scalable, making each member of the swarm less demanding in terms of resources and making them more power, energy efficient. One such system of swarm is the LIBOT robotic system that involves a low-cost robot built for outdoor swarm robotics. The robots are also made to have enough provisions for indoor use via Wi-Fi, since the GPS sensors provide poor communication inside buildings. Another example of such an attempt is the micro-robot, built in the Computer Intelligence Lab at the University of Lincoln, UK. This micro-robot is built on a 4 cm circular chassis and is low-cost and open platform for use in a variety of swarm robotics applications. Potential applications for swarm robotics is indeed huge. It includes tasks that demand for miniaturization, like distributed sensing tasks in micromachinery or the human body. One of the most promising uses of swarm robotics is in disaster rescue missions. Swarms of robots of different sizes could be sent to places rescue workers can't reach safely to detect the presence of life via infrared sensors. On the other hand, swarm robotics can be suited to tasks that demand cheap designs, for instance mining tasks or agricultural foraging tasks. Also, some artists use swarm robotic techniques to realize new forms of interactive art. Much more controversial than the above-mentioned uses of swarms, they can also be used in military to form an autonomous army of their own. Recently, the U.S. naval forces have tested a swarm of autonomous boats that can steer and take offensive action by itself. The boats are unmanned and can be fitted with any kind of kit to deter and destroy enemy vessels. Most efforts have focused on relatively small groups of machines. However, a swarm consisting of 1,024 individual robots was demonstrated by Harvard in 2014, the largest to date. Another large set of applications may be solved using swarms of micro-aerial vehicles, which are also broadly investigated nowadays. In comparison with the pioneering studies of swarms of flying robots using precise motion capture systems in laboratory conditions, current systems enable to control teams of microaerial vehicles in outdoor environment using GNSS systems or even stabilize them using onboard localization systems in GPS-denied environment. Swarms of microaerial vehicles have been already tested in tasks of autonomous surveillance, plume tracking, and reconnaissance in a compact phalanx. Besides, numerous works on cooperative swarms of unmanned ground and aerial vehicles have been conducted with target applications of cooperative environment monitoring, convoy protection, and moving target localization and tracking.